Hello, everyone, and welcome, Lalit. It's a great pleasure to have you with us today. We have known each other for quite a few years now. And so, for those who are joining us today, we'll be talking a deep dive into AWS event-driven architectures. And with Lalit with us today, I hope we'll learn a lot about how to build and scale event-driven architectures. Quickly, for those who don't know Lalit yet, so he is a cloud architect with senior cloud architect with more than 20 years of building and scaling cloud infrastructures. And every time I talk to you, I'm amazed by the scale at which you operate. And also what I appreciate the most about you is cutting the noise from the hype and the signal from the hype and going deep into even the most recent topics. We were talking about AI the last time, and I was impressed about beyond talking about AI and the hype of AI, what does it look like when you put it in production and you operate it and you scale the entire organization with it? All right, so maybe I let you introduce quickly yourself, Lalit, and we have a presentation as well. Thank you very much for taking the time and putting the presentation together for the quality of our session today, and then we can get started right on the technical things.
Yeah, so first of all, thanks for having me, Shafiq. And I definitely, I've been a big fan of a Brainboard since inception or even from the beta days. So I love to work with the likes of all the clouds. Before I work with the AWS, I work with the Azure, and before even that, PCF, Pivotal Cloud Foundry, if some people still remember it. But yeah, it's fun, and I think Brainboard adds a tremendous value. And this series itself, I believe that there will be many more fantastic speakers after me also that will contribute. And I think all we share the common goal of bringing the best of the community and paying it forward.
Thank you very much. Yeah, and talking about the guests as well, you gave a hint to the audience. We started this series of webinars called Engineered, and the goal is to bring quality guests and experts to go deep into the conversation. And Lalit is the first one, so you will be opening the stage for all the great guests that will be coming after you. All right, so we'll be sharing the screen, and so the presentation we can. This is the presentation that Lalit prepared for us. Thank you very much. So we'll take it as a technical conversation. We'll be also going into the technical details of how building things. It's not just at the high level, but we'll go deep into the technical aspects. So for the audience, feel free to ask questions. Feel free to drop any questions. I will be monitoring the chat, and we'll be taking the questions. We do pauses like in 10, 15 minutes to take the questions. And the stage is yours, Lalit.
Yeah, thanks so much. I think what I'm sharing today itself is not just some sort of a theory. I want to just have sort of a workbook or more to share in terms of after publishing my book. So these are the hard-learned lessons and some of the insights that I have gained after running and operating the systems in production for the large enterprises. But not necessarily. I have friends in startups, scale-ups, and all sorts of all across the world. So in AWS community, we talk about a lot about the serverless and event-driven architectures, which is my two favorite topics. So next slide, please.
Yes.
Yeah, so this is more of my introduction. So I recently just launched a book, finished the book and launched it with the PPB publication. Its name is Mastering Event-Driven Architectures with AWS Serverless Services, mouthful. But what you can say is EDA on serverless. That's the book with the PPB. I'm senior architect, and before that, even I was a engineer and grown to the ranks of principal engineer. And then nowadays, I'm working as a solutions architect in GP, Globalization Partners. So some of my biases, AWS for sure, because it just works, just like your Macs. AI is not a tool. I think everybody's talking too much of the AI part today, but I think, as Shafiq rightly said, signals are more important than the noise. EDA and DDD, it's a domain-driven design for those who don't know. But I believe that this presentation is coming from the rich heritage of DDD experimentation, as well as running the systems with the domain-driven architectures in the production. And my first AWS usage goes into like 2006. As I said, paying it forward. So I learn a lot from the community. So I share a same a lot of my insight and sometimes even my learnings, even if those are the failures. So I've been rewarded by AWS for that community work for 6 times nowadays. Now, since the inception of AWS Community Builder program, I've been AWS Community Builder.
And by the
All
way,
right.
for your last book about event driven, I read the book. It's an excellent book that I recommend to everyone building and scaling the event driven architecture. So I think this is one of the rarest books where you have a very good dose of technical aspects, not just talking about the theories, and that you can use it like right away. So we will put in the link in the chat, and also we'll be sharing the links at the end if someone is interested in the book.
Yeah, so let's go to the next one. So yeah, I think the general speaking in the conferences or webinars and sort of finding ourselves as a celebrity status, I think that's more of a, and then there will be always the audience. I used to be sit in the audience on the AWS reInvent and some of these conferences and wonder if I can go again after inspiring like hearing the inspiring speaker. I used to go back and say, okay, can I implement this? So it's like conference driven development. What you heard about or hear about more often is the marketing talks, or even some of the practical practitioners have their own biases, including myself. So definitely that's the reason I wrote the book. But I think more or less it's a promises of scalability, loose coupling, and you can deploy faster. You can be kind of a AWS, like your teams can be really shipping the things faster. And everything will be millisecond responses, and your cost efficiency will be like you'll not be paying too much of amount for the AWS or your value delivery. That's kind of a promises that you hear. But my experience goes in the, like when the system goes into the production and you have to operate it, and your pager duty alerts wakes you up at 2 a.m. in the morning. That's really a nightmare scenario. You are struggling to get the what happened in your service. Is it your service? Is it somebody else's service? Did you receive your service receives your events correctly? Is the system where the, if you are an enterprise architect, your situation is really worse, because you have to figure out the flow, and at the same time, if your customer is shouting, that's really a problematic scenario. So that's more of a reality of what happens if you don't do the EDA in correct manner, or say you try to cut the corners. So I think what I'm trying to say is whatever you are doing as a part of EDA or any kind of architecture style, whether it's EDA or not, you need to understand the trade-offs and understand the cost or price that you're paying for choosing those trade-offs as an engineer. I think that's the gist of it. The next one.
Yes.
So yeah, EDA struggles, especially I think you need to have your environment set up correctly as an organization before even goes to, like, EDA is supposed to be an engineering topic, but everything starts with the organization structures and team topology. So Conway's law, it follows the Conway's law. So if you get 3 teams, you will get a 3-pass compiler. If you get 2 teams, you get a 2-pass compiler. That's in short my version of a Conway's law. So EDS struggles when you have specifically really distributed teams in terms of not just geographically distributed, but also the teams are siloed in terms of devs, ops, QA, support, L1 support, and all those security and infosec, which is predominantly the case in more or less in the enterprises. Not every enterprise acts into silos, but the organization structure or organization chart needs to be it's always divided. So that's the environment EDA will struggle definitely. You will have some sort of a cap boards which is blocking your releases, or you have a code freeze. So that
Yeah.
kind of scenarios you may struggle to implement the EDA. That's a first and foremost warning. If you are a senior leader in your enterprise or in your organization, I think you should consider twice if some enthusiastic principal engineer or engineer comes into the play. I think one more aspect is whenever some engineers hear about EDA or they read the books, they are convinced that it's the right system for their own teams. You should not look into the silos. You have to look into the full body experience or the full enterprise, and then embrace the architecture style. It's not really a design pattern, it's architecture style, which means it has to fit to the entire product, not just for your domain team or bounded context team or the service team. So you cannot do one service and say, okay, I want to do the EDA in this service. That's not how you should be implementing the EDA. Generally, EDS thrives in when you have cross-functional teams and they are working together collaboratively. Platform teams provide the self-support infrastructure, or your team itself is writing the infrastructure in terms of Terraform CDK or using the solutions like Rainbow, and you're just shipping on your own. So your team itself is a owner of your own destiny, right? So if you are operating in that kind of environment, that's where EDA will definitely becomes a second nature to you, and you will not even think that any other way. And essentially, those are also kind of new modern enterprises or organizations like of AWS, Netflix, or Shopify, and many others, basically.
And
Even there are startups like Brainboard and others who are working on these kind of infrastructures. Sorry, go ahead, Shafiq.
yeah, I was wondering about the role of developers, like in the equation. Do you see them usually included as part of the ownership, or it's more platform engineering, like DevOps, cloud architects, platform engineers?
You need to have a role, but your role should not be blocking for the contribution. So some sort of collaboration, respect, and psychological safety, those features are important so that you can collaborate. And the reason for this is otherwise generally that I have seen the teams goes, or the team leader goes into the lot series of meetings and just discussing and debating about the contract or specific data fields. That's really not a productive session or use of your time as an engineer for your company or for your customer as well.
Okay.
So what we will discuss today itself is I want us to have discussion and probably even some sort of agreement upon two things. One is this session is really about the discretion, what you should be thinking of when you're trying to take some architectural decisions in terms with respect to the event-driven architectures and with respect to the serverless. And also, I think everything comes with the trade-offs, which means the pros and cons and benefits and disadvantages. So you need to you just don't need to decide on your own self. You have to share that decision with respect to with your team or with your organization in form of areas, etc., so that the communication flows. That's the crux of it. But sometimes engineers struggle for organizing or spelling it out as in their rational. So this is my contribution and help for the community, saying this is how you should be able to contribute. Of course, there are so many things that we cannot cover in a 1 hour session, but feel free to talk to me afterwards also, or even talk to Shafiq afterwards, and we can get back to you.
Yeah, and for those who are on LinkedIn, because we are streaming on both LinkedIn and YouTube, so feel free to connect with us, Lalit and I, and happy to answer any questions. And Lalit is open to answer any question.
Yeah, so the last slide has the diagram of something called, as I call, as a central nervous system of a human body or human anatomy. It starts with brain, and there is a backbone, and inside the backbone you have a spinal cord, and the whole thing, or the whole central nervous system or our nervous system of a human body, constitutes or composed of the neurons or nerve cells. So that's my analogy and metaphor for the event driven architecture. So if you do it event driven architecture in well designed manner, basically it will serve as a central nervous system for your entire organization. So growing the new cells, new neurons, and growing your intelligence of your entire enterprise or work and value delivery to your body, which is your customer and your stakeholders, will become way, way easier. So again, if you focus on the brain and spinal cord, that's the more critical part of it. And we will get the reference of the same image again afterwards also. So let's go to the next topic. So yeah, I think the first discretion, we talked about discretion and decisions, right? So the first obvious question itself is why you should have even used the EDA. So multiple, if you are in a situation where you are operating a large scale system, having multiple teams, and they are having needed to have some sort of a mechanism to share the data, um, asynchronously, definitely that's your through the business events, then you need EDA. Same thing for your traffic pattern. If you're they are having spiky traffic patterns, especially if you're thinking of your writes of the system and reads of the system, then if you're seeing uneven patterns across your reads and writes, definitely you should think about the EDA. When you should not think about the EDA is essentially when you need a strict ACID transactions across the system or strict ordering guarantees, as well as you have some sort of a very low latency systems. For example, the telecom regulatory systems or some sort of streaming system. Probably that's not a signal. I would like to talk about one more thing is usually enterprises recover from the mistakes of the architecture and startups does not, and it's game over for the startups and they are literally have to survive. So if you are into the scale up or startup, definitely you should not start with the EDA. I would not recommend that. And specifically, like your team is small and you're just operating as one single unit or a SWAT team, then probably that's not the right scenario for you to go big. Probably you can carve out a small sort of a functional area and you can start with that, or maybe the partners area. That's a good area for you to start with the exchanging the events and event streams. And the most important part I have seen, despite of all the other factors which are good here, if your team does not have distributed system knowledge, they have not operated in production the distributed systems, whether it's a scale or non-scale, I believe you will do the lot of mistakes, and sometimes it's a costlier for business. So treat your path carefully and understand that you should not be doing any kind of experimentation on behalf of on cost of your customer. If you want to do it somewhere, do it on the lower environment. So the critical question itself is, can your business process tolerate the eventual consistency? So now we are coming up with the new term. Eventual consistency is nothing but a fancy way to say I will deliver your update afterwards, or after certain seconds, or after certain few seconds, right? So if the answer is no from your business person, probably that's the another area, or that's another discretion that you need to take, whether EDA is the right thing for you or not. And EDA adds a lot of complexity because it's a nature of a distributed system. So yeah, I think that's the variables that you should consider when you think of going with the EDA.
That's a very interesting one because it's like the first criteria to decide is whether you need an answer from your system like live, or you can tolerate asynchronous communication, right? That's the first distinction. Okay.
And there are ways and to mitigate it, but again, it's advanced patterns by which you can implement. But again, that adds a complexity, and you need to have certain maturity in terms of your CI/CD pipelines and deployment patterns and even integration patterns. So I would not advise that to go with the small team and having that much of complexity. So more or less, these are the four components of any EDA, and every EDA. Basically, those are nothing but the event producers, then the brokers, or some people also refer. Like nowadays, vendors has merged this space. So previously, it all started with just having a brokers. So if you remember the old-fashioned RabbitMQ, it has a
Yeah.
routing mechanism and broking mechanisms as well. So nowadays, brokers and routers has become one as in integrated components. So that's where you will see only three components: producer, consumers, and brokers. Um, then events itself is a fact that has happened in the system, as in general plain English term, as an event, right? This is the event that where somebody push the command that becomes the event, right? So producers are producing the event, and they share their state or whatever that happened, which is interesting for the other team or other context or other system. That's the producers. Consumers itself is just the consumers, and consumes the event, and they react and respond to that event. There are some of the technologies that I have written there, which is the AWS Lambda, which I can act as a event producers, then API gateway. In fact, all these components under the hood runs on purely events, and you can see it yourself, like the payload of Amazon API gateway, or even AWS Lambda. You configure your triggers and you configure your events, right? And you can even test the mechanism with the events. So the whole AWS cloud, or even Azure cloud, and even Google cloud, or any case scalable system works with the event. So in modern day, if you are working, or if you are experiencing any kind of a large scale system, say like even you are watching your boring Netflix, right? Or even you're shopping on the Amazon.com on the Christmas day, you are still dealing with your event driven system behind the scene. I just mentioned a couple of things, as in services. So managed services Kafka, which is like conditions or stars, because it's a managed, which means there is overhead to operate it. Rest of the services are a serverless services, and cloud events itself is a specification to share the or do the schemas for the events inside event-driven systems. So I think the most important part in the last session or last slide was basically you do not need to know about the consumers, or producers does not have to know about the consumers, and they can work and act independently. So that's the whole promise of a decoupling, which is happening inside the EDA system, without even you noticing it or you are doing anything explicitly. So that way, even the producer is down after producing the event, and the consumers can react and respond to that event, right? Same way, if one of the consumer is down, you can still have a recoverability. So resiliency and recoverability of that system from the customer perspective, not from only technical perspective, that's very good. So essentially you're saving your SLA times, etc. And you can see it even in the case of whenever AWS has some sort of event or outage, you still get on the dashboard sometimes saying, oh, everything is fine. So
Yeah.
it's not something intentional, it's just the side effect of event driven system. Right or wrong, I think it's on that scale or on that hyper scale, you have to operate with the event driven systems. You cannot just have a synchronous systems or request response systems.
So
um,
to, Just Lalit, talking about decoupling, the way understanding is like the producer produces event as if the consumer doesn't exist, like they don't think
Yeah.
that the consumer exists, and vice versa. The consumer consumes an event without knowing any information about the producer. So it's like the state of the producer doesn't matter to the
That
consumer.
uh, the last statement itself is correct. The state of the consumer or producer is independent of each other. But rest of the is academics. Like for example, if you cannot be sending the event in a vacuum, right?
Yeah,
um, so there is no point in producing an event when there is no demand, right? You're just adding the noise on the channel, which is your broker or the buses.
makes
So
sense. Yeah,
foundationally, yes, and on a very theoretical note, however, if you have established set of consumers or even one consumer and one producer pair, and you want to add another consumer, the overhead itself is really, really less, and the producer doesn't have to do anything apart from sharing the schema of that particular event to the new consumer saying, hey, and even if you have some sort of a registry or catalog, which is having all these event schemas, you don't need those things. So consumers can be way independent as compared to the producers.
makes sense.
And it's not only schemas, it's a rate or throughput rate also. So your producer sometimes might be producing an event which is not really digestible by the downstream system. So definitely there is guardrails that you need to apply, but at the end your consumers can have a lower speed or lower consumption rate or throughput and still able to process or digest those events and do the payment processings of the world correctly. So you will not be. Of course, you need to make sure that you are not charged twice. If there is a small-
That's another. That makes sense. Absolutely. All right.
Yeah. So, sorry, can you go back to
Yes, this
last
one.
slide? So, yeah. So the core principle, I think, what we are saying here again or emphasizing is this is the bottom line of the EDA. Events are immutable facts. Event does not change. Event does you do not modify, update event. You just have that as a fact saying the moment anything as in word come out of my mouth, I cannot take it back. Similar way, you have events in a system. The commands, there is a something different kind of a construct which comes from the message driven architecture, these two terminologies. So the commands is expression of the intent saying, oh, I want you to do this for me. So that's the differences, and in the semantic or syntactical word, you should have a present tense for your commands and past tense for your event, because those are the things that has already happened inside the system and you are merely responding. um, we said one word there, another terminology, which is immutability. Immutability is just saying, I don't want to repeat, right? So essentially it enables the replay of debugging and recovery, and even you need to have immutability, because otherwise your system will be in chaos, because you are not, say likes of a previous example, you will be charged twice on your amazon.com, and that's not really a good scenario. But yeah, that's the more of a bottom line. So uh, the design choice is basically what should go in the event, right? That's what now we are trying to peel up the onion. So we talked about the cloud event spec. I think people can go and look into the cloud event spec, and they have their very nice elaborated documentation about it. But four factors in a very generic term, I would say that you need to have some sort of event ID, because you need to keep the records what has happened inside the system. Second is event type, saying what kind of a event that was and where it was originated from. So you need to have a domain dot entity dot some sort of a event name, which again in the past or past tense. The last one is you need to have a timestamp when that happened. and then what's the chain of things which has caused this particular event to be emitted, right? So you need to have some sort of a correlation ID across your across your different services. Again, you are operating a distributed system, so this is kind of a second nature for somebody who's familiar with the um, distributed system. But those needs to have in embedded in your event payload. One more thing I didn't explicitly mention here, the state transfer categories of event. There are two categories: state transfer events as well as the notification events. Notification events is more of a causes the chatty interfaces or chatty communication inside this your system, and sometimes it's okay. Then they are kind of a requirement, or I would say 80% of your messages should be notification events. But don't get it like you need to have 100% event. You need to also have a state transfer event, just so that you can reduce the amount of calls that's happening to your producer domain through the APIs or through the other communication mechanisms.
Okay. And we have a question on LinkedIn,
Sure.
because I think there is like 2 minutes, I guess, delay between the streaming and the LinkedIn. What is the very first indication that you look for when designing an application, whether it fits well with EDA or not? Is it just the asynchronous communication or something else?
Yeah, I think right now we are like in modern days again. The questioner has asked about the application. That may be the product, that may be an individual service, but I'm assuming it's in the architecture space we don't think about just the components. So yes, asynchronicity and the nature of the business itself is very important for us. Scale is another factor, and the team size. I think we covered those factors into the first slide itself.
Yeah.
But yeah, if I think it's not just the technical aspect that we look for. Like for example, asynchronously, um, we need to also discern about the business flow and what's the implication of it. If you need a strong ACID guarantees, naturally that's not the right fit for your EDA. It may be or may not be. Again, that's based upon your scenario or use specific use case, and your industry also matters. For example, despite of ACID properties in the fintech, we have seen that EDA is a very common thing.
Okay.
So because there are auditing requirements there, the teams are matured, and in-house audit trail is having more important, compliance is having more important function. So you need to think through the well architected framework. Again, that's your frame of mind should be, and then define your scenarios, and then start to think about, can I stitch all these components through the event driven system. And there is a nice technique called as a event storming. And even in my book I have mentioned the user journey mapping. So you need to think about that, the team topologies, etc. That also is another factor which is not technical one, but that matters. So it's really I hate this answer, but it really depends.
Yeah, because there is no just one factor that you can base your decision on. And this is important when you mention the team size, because like if you have one guy managing everything, maybe it's not the right choice. So, and this not
Absolutely.
technically, yeah.
All right, so I think
Building blocks.
so yeah, so let's move fast. I think EDA building blocks, I would not spend a lot of time here, but I think this is more of introduction of the services which falls into which categories. So you need to compute some sort of event routing system, you need orchestration, streaming, observability, and storage. uh, I intentionally mentioned this slide. Yes, there are AWS services, but if you are not working with AWS, you can still correlate with these constructs as in pure concepts and apply it to your cloud provider or your own environment, even if you are working on premise. So yes, these services are kind of important for us. The one small thing I will mention here is don't even if you know multiple services on AWS, Azure, or GCP, and you have achieved your 13x certifications, please keep your set of services very, very, very small, because that way you are not adding a lot of cognitive burden for your team and even your organization and peers. So it's very simplified to manage and operate if you run the tight ship and try to. I would say same thing for the multi-region. Don't start with multi-region or multi-AZ. Start simple, small. Of course, you need to have a disaster recovery and all the bells and whistles or guardrails based upon again your industry and your scenario and the budgets. But start with very small subset of a services which are very reliable, which is running from last maybe 10-15 years, and then slowly take advantage of the new services if it is fitting to your scenarios.
Okay.
So there goes my favorite diagram again. So the metaphor, nervous system. So how we should start? We are speaking a lot of the foundational stuff here in the initial slices, right? So I would say start with the brain and the spinal cord, which is your event bridge. You have everything more or less required from the broker and router perspective in the event bridge service, and it's very nice way because your operating cost, not necessarily just the price, but the total cost of ownership for event bridge is way lesser as compared to if you want to go with the Kafka managed services or some other solutions. Same thing, once you have the event bridge established, you can have a rules and you can hook it up with the SQS for making sure your consumers can nicely consume the or respond to the events. And it acts as also as a buffer, so you have some leeway in your engineering, so you can pace it out the value delivery, as well as then you can go for the incremental emerging patterns of your EDA. So you are not overwhelmed with what I'm trying to say is you should focus on this whole point of a serverless mindset is you should focus on your customer and knowing your customer and serving for your customer and the value delivery. So think from your somebody has to pay the bills, right? And we are serving or we are here only because they are here, right? They are paying the bills. So think from that perspective. Despite however passionate you are as an engineer, you should start slow and go in a very incremental fashion. So it's going to be helpful, and it also generates a lot of trust, which is not really a it's a one-on-one for any kind of architect. But this is important. I have seen many times engineers are debating about the Lambda or ECS or should I use the event bridge or not. But they miss the point of saying we are here because we need to do the value delivery, not just the fancy engineering work.
Yes. And now we take a few examples, maybe.
Sure.
Yeah. Let me share my screen on the architecture of the examples. So this is like a simple architecture and serverless architecture, and the different components that you were talking about, right? Like from the producer, where it comes from the business to the backend. So these are the components that you have, the AWS components that you have. So if you can explain like the workflow quickly.
Oh, sorry. Yes. So essentially, think of it like some sort of an e-commerce website. You're purchasing or shopping something. You add it to your basket. The moment you add it to your basket, your event is getting produced, or once you check out. So that's when your order is confirmed or order is complete. So your front end system is connecting to the back end system, and there is somewhere in that service there is a event that is getting produced by your order service called as a order complete. So that's the event which we are seeing from the towards the right side of the screen. So that event itself is going through the event bridge, and based upon the rule set that is configured, this event is needs to be distributed to the downstream system of shipping and payments. And you can notice that there is a FIFO queue for whatever the reason, because you want to maybe probably serve on the first come first serve basis. So you can have ordering guarantees, and that's the reason you'll be able to see the FIFO queue there. If you are not worried about your ordering guarantees, you can have a standard queue. But these are the nuances when you start thinking about these things and you go into the nitty-gritty details of, say, configuring the whether I should use the FIFO queue or whether I should use the normal standard queue. Then both the queue has a different cost structures, right? Going back to what AWS lot many times teaches is you have to work backwards. You need to know your customer. Again, you cannot just have that theoretical um, cost calculation exercise unless you know the traffic patterns of your system in the production. And you cannot know the traffic patterns of your system if you don't have the observability, you don't know the customer, you don't know what's happening in the production system.
Yeah. And there is also the next part, which is the infrastructure for the EDA. And so, yeah, if you can help us understand, like from now, zoom in, into the details, like we have the API gateway, the VPC, private components, and so on.
So the nice part of this whole architecture itself is the moment you start having the AWS account, you can provision all these resources with the infrastructure as a code solution, whatever you are using, whether it's a Terraform, Pulumi, CDK, or even Brainboard for that matter. The good part is you can use different services what has been allowed in your environment or has been enabled in your environment. Choosing the region itself is a decision, and of course the different services and selection of the services I have touched upon in my presentation afterwards, so we'll see that. But predominantly, again, it goes back to what is the system you're operating, what is the kind of traffic pattern you are seeing. I'll give you an example which we will talk later also. Like if many people think that oh, Lambda is the only, the moment they hear serverless they only think about Lambda, which is really not the case. Lambda is good for starting anything. If you don't know your traffic patterns, if you don't know anything, you are starting as a new company, right? As a startup founder, I would say start with the serverless, because you are a one single guy or maybe couple of guys, and essentially what you're trying to do is prove the business value of your solution and then survive. And you need to manage your cost. So when we say cost, essentially it's a price here, but as your system grows, probably you need to have a read side of the your partner is demanding that read side of the thing should be faster or having a ultra low latency. Then you need to think about the ECS or Fargate, which is way apt solutions as compared to Lambda when it comes to these kind of scenarios. Think of something like machine learning nowadays, the training mechanisms, right? So for the training of the AI/ML pipelines or the data pipelines, you cannot finish the job in 15 minutes. That's the constraint that Lambda has. So unless you know your services really really well, and that's the reason why I'm so much adamant about choosing the very small set of services and starting from that. And this is what we are seeing in this solution also. So if you see this solution on the really top hand side, you have some sort of orchestration workflow. That's again the batch workflow. The choice of the solution here is the batch workflow, and it can be implemented with the step function. So it's not really the point which many people over miss, or like they miss, is every service has its nuances, and for a very specific purposes AWS has designed those services. Like you cannot replace lambda with container or lambda with the step function. If that is the case, or if you think that is still working in your scenario, probably that your scenario is really very small, minute scenario, which and you may not be thinking about the whole entire system or product. You probably is thinking just a small component of it.
All
And
right.
the good example of what has been hyped last year was Prime Video. So Prime Video team started with Lambda. They learned their lessons. They understood that somewhere we need containerization, but the hype was really misinterpreted by the media and the social media itself. So it is not a vice versa, or it's not a competitive battle between the AWS Lambda team or Lambda, etc. You're paying the bill anyway for the compute. All these are compute, right?
Makes sense. Absolutely. And we go back
Sure,
to the rest of the presentation
sure.
and
So
the invocation of Lambda.
yeah, so we'll touch base upon it. It's more of a details again. So there are again, this is diving deep and making sure that we are, the moment you try to take some decisions, you have to understand those services inside out. You don't need to like read all the documentation, but I would say don't go anywhere else apart from AWS documentation, because AWS is launching or even silently launching many features. um, so AWS Lambda is having or offering three types of invocation: synchronous, asynchronous, and pool based. Many people doesn't know about, and most of the people know about the asynchronous invocation because that's the bread and butter for the AWS service, and you can see that in the interface itself. However, synchronous APIs also exist, so which means you can send the request and you can actually invoke the Lambda just by HTTP request. You don't need to trigger that as an event. Okay, so that's a synchronous mechanism. There are triggers which you can configure, say from API gateway or application load balancer. Those are the examples of services through which the synchronous invocations work. Asynchronous invocations, we all know S3. Sometimes somewhere you might have been dumping the documents and having object created event process, right? So that's your S3. SNS is a fan out pattern, so that's kind of obvious. Poll based invocation is quite interesting, and it happens when the Lambda itself keep polling. Not necessarily it is shown to the or visible to the end customers like us, but under the hood, when it comes or when you hook it up the Lambda with the DynamoDB streams or Kinesis, it is acting based upon the poll. So it's actually old fashioned way of hey, is it done? Hey, is it done? And it
Yeah.
keeps doing the things, right? So don't choose the services just say because, oh, I have read that this is a serverless service and Lambda is the best fit, so I'm hearing every time serverless equal to Lambda. That's a misinterpretation of it. You also need to think about kind of gotchas and traps. For example, I have mentioned one of them. So when you do the stream processing through the DynamoDB or Kinesis stream, your one poison message can hold the whole pipeline, and it can just clog your pipe. So you have to configure it like the DLQ and the other of the mechanisms. So your choice of service is not just dependent on what is written on the front page of AWS. I think that's kind of obvious, but you also understand that, again, going back to your scenario, your use case, what is the appropriate mechanism that will fit? I think somebody has asked that question, so we are going deeper on that, other different dimensions and the decision factors. So error handling needs is also another mechanism or dimension that you need to think about, saying what if this fails. And as famously AWS CTO Werner Vogel always say that everything fails all the time. You need to think about that scenario.
Makes sense. We have a few questions, but maybe we can progress on the slides and we can take the
Yeah,
questions after.
sure.
Just mindful of the
And
time. Yes.
I hope that some of the questions are also we are able to answer through the slides. So Lambda excels when your traffic is spiky, I think, or bursty. Function execution, we talked about this, so I'll not reconsider. But this is not a debate about whether I have to choose Lambda or Fargate. I have done the services in the large enterprise or telecom sector where we have both, and I will give you example. So on the read side of the house, I was using the ECS very well because we have to have a search result as an enquiry and a read model. And on the right side, we were processing the event from the other domain and then pushing it into the in fact DynamoDB. So you can combine those services and compose your solution. You don't need to just it's not a debate about this about that that service. So pick your battles, and services are the equal or same I would say for AWS. So you are paying the bill. Again, the cost crossover again is a matter. So I would say that there is a tool. I'm forgetting the name, but it is from the Alex Casaboni for the cost calculation, and you can use the AWS pricing calculator also. But yeah, that so again we are introducing a new factor here. Apart from the error handling, you need to also think about the price and cost calculations, and you can still combine multiple services despite of whatever the bias the media or LinkedIn is sharing.
Yeah, interesting. I mean, the FinOps to be part, like a native part of the thinking, is not an add-on later when we need it.
Yeah, and this is all these factors are you don't need to get overwhelmed about it. You need to think about into this is where the AWS well architected framework comes in a play. So you need to start thinking about all the pillars or 6 pillars of the AWS well architected framework, and that will give you the answer. Even if you dry run in your mind, it will help you out. Orchestration and choreography, I will not spend a lot of time here. We need to fast track some of the things, but essentially orchestration itself is a central coordination, just like your brain, what we have seen last time. And choreography is just your choreography, which means the services are collaborating with each other, but they are acting independently. They are not waiting for a central command to be issued to them. So some of the strength of the choreography is loose coupling, autonomous. You need to have autonomous teams and resilient to single point of failure. I would say the last part, which is really, again, this is the same thing. It's not Lambda versus ECS or orchestration versus choreography. You need to use both if that fits your scenario. And some of my guidance or my own insight is orchestrate within your context boundaries or service boundaries. And when you're collaborating or going across the services, you can choreograph between them, and that can serve you the middle ground.
It makes sense.
Idempotency, I think we are touching again the nerve of a whole EDA part. So because of the distributed system policies, this is kind of obvious. The very easy hacker solution or a programmer solution or cowboy solution. Oh, I will just configure my retry in the Axios or whatever the client library you're using for your HTTP clients, and I will be able to send a lot of repeat or requests, retries, right? And then there is a retry storm, and then your downstream service is just suffering because they missed to implement the deduping of the things or idempotency inside the service. The good part is AWS Power Tools are giving you this as a out of the box. So I would highly recommend just implement the AWS Power Tools, get it in your service, and get the benefit of idempotency. Let's go to the next slide, please.
Yes,
so that's the same.
Yeah.
The only catch here is the cost. because you are adding one more store there for your idempotent or the IDs, you are essentially adding the storage cost there. Uh, yeah, so observability, I think observability is a necessary thing. We talked about it. If you don't have observability and monitoring solution, you are flying blind in the production. You don't know what you're doing. And despite of however nice engineering, or even if you are passing everything else by flying colors, I would say you cannot launch in the production. You're just fooling your own self. Some of the things I sorry, Cook, can you go back? I want to
Yeah.
touch this upon the last point, which is this is what you need to budget for. This is kind of some executives or leadership people, they enthusiastically go for the scaling of the system or require scaling of the system, but they don't understand that the inherent observability tax or the cost, because of the sheer nature of, say, I want to have a logging in all the four environments, right? But they have not anticipated saying in the dev and lower environments we will be having debug logs on, so your cost will be multiple folds unless you curb your engineers with the guidelines, right? Which is really not the case most of the time. So get prepared for, if you are a director or senior leadership in your engineering organization, make sure that before embracing the VDA, you are also factoring these kind of a cost. And you, as an engineer, you should be making aware your leadership about these kind of nuances about the architecture style.
Yeah.
Yeah. Failure modes. This is my favorite topic. I always think about saying what could fail, and that's a fun way to work with the distributed system. So, couple of the patterns or the standard, let's say, failure modes that we have observed is poison messages is basically corrupted message in a very layman's language. It may be malformed schema, malformed logical elements which should not be there, just because producer team has introduced the new schema without telling you, they slipped in without versioning inside the event. That can become a poison message, or that can corrupt your consumers. Downstream outage, that's kind of obvious. Throttling storm, I think. We have seen this lambda concurrency is configured very less because of the account limits, and you're getting a lot of throttling errors, and nobody's noticing because even your DLQ alerts are throttled. So that's kind of a fun. So I would say that you need to just make sure that if you are having EDA, your synonymous failure recovery mechanism should be DLQ, the dead letter Q, if you don't know the short form. But yeah, and don't ignore your DLQs. In fact, I was the one who was constantly nagging AWS for having it as a by default provision. They have improved after a couple of years, but it's still not automatically provision. I want this, like the moment I'm configuring, say, Lambda or anything, I need to have a DLQ coming out of it, as in inbox, like off the shelf, right?
Yeah. What I like about here, this is like the most important thing to me is the mindset shift. What you said, failures is features. So this is the key element here. It's not like, oh, a bug, I need to deal with it, as a bug and put it in a ticket or whatever. This is, I need to design for it.
Yeah, I think that's a game changer. In fact, very well said. It's usually when, at least in my journey, when I was moving from startup to the fintech enterprise, it was shocker to me saying, oh, something has failed, and they were saying, oh, don't worry, we have taken care of it. And I was really curious, like how you are going to take care of it, or how it is taken care of. And I understood that they have the DLQ hooked up to the Slack or Teams messages, and they were monitoring the DLQs. And in Verizon, I would say we were so well versed in these patterns is before even customer realizes their specific expenses or invoices has failed, as in they were uploading some spreadsheet, we were reaching to them and we are recovering their workload or the job, and making sure they get communicated that their spreadsheet was not well formed or anything whatever else. So we were, again, this goes to the team topology points. If your work, because support was embedded into our teams, and we were right away immediately can get on the phone with the help of support and say, hey, or send the email or alert saying you tried to upload this, but we know that, and yes, eventually we automated that whole mechanism. But yeah, you can be way smarter and gain a lot more trust by just doing some good engineering practices. That's one of the examples.
Absolutely. Yeah.
So two patterns are very common or commonly talked about: CQRS and event sourcing. I would just go for CQRS. CQRS is command query responsibility segregation. So it's a fancy way to say you need to separate your reads and writes. So system, and this goes to the Unix philosophy, which I really love. You simplify your instruction set, and that way you can actually operate a great system or a reliable system. So that's more of a CQRS. I have implemented CQRS as well as event sourcing. Event sourcing is really, if you are coming from the .NET world like you were at one time fancy about Greg Young's and DDD, you might have get a glimpse or touch of it in terms of event store. I would say event sourcing itself is very complex one, so I would not recommend anyone to go with it. CQRS, yes, you can go with it, but don't make it your world complicated unless you require. Try to keep it simple. Keep it simple with your selection of services. Keep it simple with selection of your operations. Don't try to merge that operation, and this needs a clarity of thinking. It's not anything else. But yeah, it's a nice system when you need to have a way differentiated reads and writes. For example, we were uploading the documents and showing those documents to the end user. So that documents were written on the S3 or uploaded on the S3, and then we were getting the event through the Lambda. And essentially that was the like, and on the read side, we were providing the search feature to the end user through the Elasticsearch. So even that kind of asymmetric models you can implement using CQRS, and very like with the small amount of cost if you are using serverless.
And here you have a
real
life example.
Yeah, so this is a real life example of very small a scenario where there is a medical clinic, and we are trying to book the appointment for that clinic, and there is a website on which the customers are seeing the block, the blank or empty slots, and booking again the appointment. So there are practically two services: practice website service and assignment attribution service. So usually when you drew the diagramming, I would always suggest that you need to have a logical view, so which is agnostic to your deployment architecture or selection of the technologies, and then go for, say, AWS or Azure or whatever the architecture choices or physical implementation for that. This itself is coming from my book. I thought about a lot how to clarify and help everyone who's getting confused about or overwhelmed about so many things that has been shared across or even on the inside the book. So this is my way to help. So this is the algorithm for solving, saying if you need a pattern, how should you go for? So you need to think about, I think this goes to the Maxim question again. So think about the consistency needs. Do you need a strong consistency? Do you need an eventual consistency is okay for you? Again, if you are thinking about the consistency model, you also can think about your scale of the system, nature of the system, and the business itself or the industry you are into. Select the event volume or workflow complexity if you are trying to go for the workflow. And based upon the choices of high, low, medium, you have different services or even patterns that you can implement. Every pattern comes with the failure handling mechanism and the complexity or trade-offs associated with it. So even if I'm not shown rest of the failure handling, I think you need to work it out yourself. But yeah, that's a framework of mind or pattern decision framework I always use, knowingly or unknowingly, when I'm going for selection.
You know, when I read your book, I screenshot this exact diagram because uh, it helps me. You have a shortcut to take a decision. You don't think about
Yeah.
every single detail. You have it there, and this is a very important one. Thank you for sharing it from your book.
Oh, thank you so much. I think this is another one which is that was a framework for selection. Now you have selected one of your mechanism. How you want to select the pattern which is associated with some of the previous pattern is, uh, and this is again really going back to our theme of saying what's there, what's the trade-off you are choosing for your well architected framework or consistency, scalability, complexity, failure recovery, as well as cost. So based upon each of them, again, this is coming from my book. So if you want to expand on this topic also, I would suggest that you can go and read there. Uh, but yeah, like for example, CQRS we talked about. So it's excellent, or consistency is eventual consistency here. You need a excellent scalability, then you need to go for CQRS. Complexity, again, this is subjective, but still I would try to calibrate it based upon it will have a medium complexity, because if your reads fails, sorry, the writes fail, then your reads will be need to be rehydrated, right? So you need a failure or recovery patterns or resiliency patterns to be implemented. So yeah, um, and essentially the advantage that you are going to get from the CQRS is, yes, you can tune or performance tune your read side completely differently as compared to the read write side. You can even use different technologies even in the same domain, like we were using for say S3 for document storage, and for all the metadata and rest of the storage of that metadata was maintained into the Elasticsearch. So rest of the things I would not read, but transactional outbox is another pattern which you might find it very useful. I have described it in the book, and even you can find it on the integration patterns website. But yeah,
Yeah,
so all in all, I think these are the trade-offs that you're always selecting as an architect if you are going for the EDA. And my book expand on a lot of topic that we have not covered because of the time constraint, like security, fault mechanisms, as well as cost modeling.
yeah, and now lessons from production incidents.
Yeah, so these are the some of the things I have also seen, again in my whole career. I am fortunate to do the less mistake but observe a lot of mistake from others or say other teams, and it was just a fun ride, because I am just fortunate enough to work on the large enterprise scale systems. But yeah, event spaghetti is one where you will see everybody publishes everything, and then it's a circular dependencies, and nobody knows what's the catalog. So there is no existence of a catalog there. And because of that catalog, there is a because of the organization dynamics also, sometimes the service boundaries are hazy. Somebody has to influence them as an architect, and draw them into the solutions, into their whatever the wiki that they are using. But yeah, this is again the same thing. God event is another thing, saying, "Oh, you ask us the event, so I'm going to give you everything, even if you don't are like required as in consumer." So they are spilling their own beans. They are sharing the private data of that service, which is really not required, really not consumed by your consumers. So I would say, despite decoupling and what we promised as in advantage of EDA, have a sort of a user group with your if you are a team lead or tech lead of your producer service, or you're working on a producer side of any flow, you should always have a constant communication or certain frequency communication with your consumers and listen to their feedback. So that way you are enriching your event. So it's just a human to human connections. Despite the standards are set, everything is there, it helps a lot to get a feedback. And again, it's the same philosophy. It's a customer focus and customer obsession. So you need to have that and treat that interchain of end customer or the external customer to the internal customer. But yeah, so that's more of a god event, sync in disguise. So producer waits for consumer response via another event, and we say, oh, we are going to send the ACK, right? Sorry, it's not a TCP communication that or the TCP communication protocol we are discussing here. So you need to make sure that that indicates a smell in the EDA, and essentially what you are required there is more of a API or request response instead of having back and forth events. So that's the overuse of events and stamping everything as an event. Instead, what can be worked with the plain simple synchronous request. No DLQ, that's a disaster. If you want to ship anything in the production, I would say forget about the whole hour what we talked about and just implement the DLQ. That will be worth of this whole presentation. Then unbounded fan out. I think this I have seen rarely, but I have seen sometimes, especially when you have external integration partners likes of a ERP system or CRM system or some sort of a vendor you are working with or partner with, and because their services are sending you because of something happened on their external system, you're getting the storm of a request, and you're just essentially triggering thousands or hundreds of lambdas or whatever you have as a downstream system impact. And that's a thundering herd problem. Again, it's a well-known in the distributed system world, so I don't need to explain. But yeah, you can fix it with the rate limiting and SQS buffering or concurrency. Optimistic processing is very simple. It's just last one wins, right? So we talked about a lot into this session about idempotency. This is another win. I think DLQ and idempotency, if you do these two things well, you are at a good start on the EDA. And by the way, the power tools, AWS power tools, thanks to that team, they have implemented this as in a standard pattern. You just need to just inherit that dependency and make sure that you're implementing or enabling that flag and configuring the DynamoDB for it. All right, so some of the things that we have covered here, eventual consistency as a UX problem, we didn't talk about it, but I think that's the important part. So many times the user interface, like as in requirements come, your designer, web designer does the Figma or whatever HTML prototypes, right? High fidelity or low fidelity prototypes. And the stakeholder gets surprised when the system reaches to the production, because they are saying in one widget the status is green, another widget the status is red for the same order. So it's a conflicting signals, which is saying what the heck is happening, the system is not acting correctly. So that is disguised as a UX problem. So you need to work with your designers to make sure that they understand what eventual consistency means. And you can give a very well example of say Facebook or LinkedIn red, or sorry, the Slack green dot, right? Sometimes you will see that's again, Slack also works on a synchronous communication or EDA. So you will see sometimes it's on and even the person is off, or vice versa. Cost inflation points, you need to know your services and make sure that you also think about the cost. Otherwise, you will get a AWS bill shock. Again, if you don't know anything, you are a startup, just configure the budgets and budget alerts in your AWS account. that's the simplest part you can start with. Of course, there is a cost explorer and add more advanced services nowadays, and the whole FinOps has been adopted as a practice on AWS itself as in engineering practice. And yeah, you cannot be successful despite of everything you are doing correctly if your organizational structures and team topologies does not support the EDA. And one more last slide, please.
Yes, this is the takeaway, the things that we
Yeah,
should remember as engineers.
exactly. I think if you want to Photoshop it or take a screenshot of it, this is the slide. EDA is a trade-off, not a silver bullet. I'm not selling you EDA or go ahead and now finish the EDA or go ahead and just because you read the book, do the EDA. Try small, start small if you are interested. For sure, you need to understand, you need to have all the tool set in your tool chain. So EDA is one of them. Idempotency is not negotiable. So no matter what you do the DLQ, do the idempotency. Observability is a huge investment because now you are not dealing with the single call stack in your monolith or a single small process. You have to figure it out what happened in each of your processes or programs or services. Eventual consistency is a UX problem, so get your don't give your business users shock saying something is wrong in the system when it reaches to the production. Talk to your UX guy or the designer way upfront so that he understands or he or she understands basically how the user experience should be surfaced in a correct manner which supports the architecture. It's not a friction or it's not a fight between UX and the architecture or backend systems. Orchestrate within your boundary of service, business context, or whatever you're calling, and choreograph across them. That's the easy way. Talk to your customers, internal, external, all the time. It will help you anyway. I think that's more of a gist. I think at the end of the day, what we are trying to do is taking the decisions and well-informed decisions. Those decisions comes with the trade-off, and we need to make sure as an architect or any engineer we are communicating those trade-offs. My book does not go on to the how part saying how you to use this service. Of course we have covered the services also, essential services on the serverless side, but I think what I try to do is try to ship my experience, zip it up into small consumable package, and make sure we are condensing to all the decisions. So my book is more of architecture and suitable for the principal and staff engineers and senior engineers. But yeah, it's and afterwards, if you want to connect with me, you have my LinkedIn, or you can also go and purchase the book and fire up your questions. That would be great.
I just shared your profile on the chat as well, and also we'll be doing this kind of sessions regularly, engineered, going deep dive into specific topics. So if you are not following Brainboard on LinkedIn, just do it so you stay informed. Thank you very much, Lalit, for the high quality presentation and technical details. There is, you mentioned that Maxime in your comment, I think you were answering his question on the fly. There is another question from Vishal about can cron jobs comes under poll-based invocation? Just to make sure we answer it here.
The answer is yes.
Yeah. Okay.
So essentially, cron jobs are if you are what cron jobs usually do is they are more of trying to invoke some sort of a workflow. So you can like the way I translate is cron jobs in the very old fashion. If you're doing, you can configure them or model them as a step functions or the workflows inside the AWS environment. And yes, those can be, again, if you are configuring it as a workflows, you can invoke them asynchronously. So you don't need to go for that old-fashioned poll-based job. But yeah, if you're doing some sort of a batch processing, again, you can do the pool based also. So it's up to you also.
Perfect. Thank you very much. At least the answer is in the recording. He can rewatch it later. Thanks again, Lalit, and thanks for everyone joining us today. Enjoy the rest of the day, and hopefully talk to you soon. And Lalit, enjoy your evening.
Thank you so much for having this opportunity. I'll be looking forward for the next series, engineer series, and I truly enjoyed Brainboard. I think one thing I would like to share with the audience is Brainboard is not a diagramming solution. Don't get mistaken just by the interface. Uh, you can very well go end to end deploy the whole infrastructure. So you can deploy your diagrams. That's my tagline for Brainboard. You can deploy your diagram. You can have those diagrams that gets translated into the Terraform code. Which you can modify. You can apply your all rules, etc. And it can also integrate with your CI/CD pipeline infrastructure, whether it's a GitLab, GitHub, or any of other providers. And yeah, definitely you should check the brainboard.co.
Thank you very much for your kindness, Lalit. Enjoy your evening.
Thank
See
you
you
so
the
much.
next time.
Yeah.
Thank you.